So, um, my name is Chen Yixu, and I work with Hongran Wu, Jianhao He, Romesh, and our topic is population decline and real estate valuation, assessing fertility rate influence on Japan housing market. Next is our overview. It includes introduction, literature review, data description, model selection, analyze and forecasting, and the last one, findings. So let's talk about our research topic. Why is it interesting and why we choose that? Um, it's from the new thoughts from previous research findings. In previous courses, we recognize the global trend of decreasing fertility in developed countries. Um, Coincidentally, we also cover the exponential growth occurring in world or developed world's housing market. When further researching this anomaly, we found several articles highlighting the link between housing price and fertility. And the fertility rate in developed countries have become a focus point. Low fertility rate has already led to a series of problems such as population aging and labor shortage. These issues produce a negative effect on economics. And last, housing prices are closely related to people's lives. It's not only a figure, but also related to family stability and happiness, and there is a linkage between housing prices and economic conditions. And then we talk about the fertility rate. What's the fertility rate? It's the total number of children born to a woman in her lifetime. And based on woman's age-specific fertility rate during her childbearing years, typically considered to be ages 15 to 44 in international statistical usage. A fertility rate of 2.1 is widely accepted as a replacement rate. The number of births per couple such that total population does not decline in following generations. That's the standard. But now the situation is the most developed countries and developing countries have insufficient fertility rates. Current Japan, it has a fertility rate of 1.4, 1.1.
Okay, so when researching our topic, we found multiple studies that have examined how rising house prices have impacted fertility, specifically in Japan, and with particular focus on the economic pressures that occur in densely populated urban areas, which there are a lot of in Japan. Um, Kondo suggests that financial pressures associated with high housing costs in metropolitan areas like Tokyo discourage family formation among young couples. High housing prices create financial barriers, pushing individuals to delay having children to prioritize their own financial stability. This dynamic is particularly relevant in Japan, where the cost of living in urban centers is high, making family planning challenging for younger generations. Next, a study conducted by the IMF examines the impact of Japan's migration patterns. People are moving from rural areas to urban centers. This is creating a demand spike in these cities, which is driving up housing costs. These are correlated with very highly correlated with lower fertility rates. The IMF study emphasizes that these high costs make family expansion economically challenging, especially in urban areas, adding to further pressure on fertility rates in Japan's aging society. One of the final studies we looked at was a longitudinal study from the Japanese panel survey of consumers, and this highlights the effect of housing costs on fertility. The research indicates that Japanese couples facing high housing expenses are more likely to delay childbirth. This trend suggests that the perceived instability associated with high urban living expenses discourages young families. This shows a direct link between housing wealth and fertility decisions. Next slide. So after we'd done our literature review and we looked into the topic, we moved on to collecting data. We sourced our housing market data from the Federal Reserve Bank of St. Louis. This data provides quarterly updates that reflect fluctuations in Japan's real estate market. For fertility rates, we obtain the annual data from the UN population data portal, and both of these data sets are from 2010 to 2024, which is our dates of analysis. There was a key challenge when organizing our data. The housing price data is quarterly and the fertility rate data is only updated annually. To process this, we used linear interpolation to adjust the annual fertility rate data to a quarterly frequency. This allows us to align the fertility data with the quarterly housing price data to keep the timeframes consistent. After processing, we generated 57 quarterly data points spanning from 2010 to 2024 for both data sets. It is important to note that during linear interpolation, it is helpful, but while helpful, it assumes that the changes between annual data points are smooth and consistent. This can reduce risks by potentially oversimplifying the seasonal or sudden fluctuations or shocks that could be relevant in our analysis. Just to summarize, the literature and data that we acquired help us build a strong base to explore whether Japan's rising housing prices significantly impact the fertility rates. And this is a critical issue for understanding the demographics and economic trends in Japan.
Hi, I'm Jian Hao. I'm going to introduce the analysis on the relationship between the house pricing and the fertility rates in Japan. So here we saw a clearly trend. The house price generally went up over time, while fertility rates shows a gradual decline. And then we'll calculate the correlation. Next slide. Yeah, it comes out the result is minus 0.9, which is shows a strong navigate relationship between them. This suggests that the rising house price might be linked to low fertility rates, possibly hinder delayed impact. And next, to explore this relationship, we use the VR model. And the next slide. VR is great for analyzing multiple time series because it led us to look at how each variable influences itself and other variable time. Since VR model requires stationary data, we differentiate the data to remove its trend and use ADF to test. The result is second order for housing price and first order for fertility rate. Then we use AIC and BIC criteria to find the best likeliness for the model and set on a lag of 5 to keep the model balanced and simple. And then let's look at what the VR model shows us. The result related to a strong autocorrelation in housing price means that the past price significantly affect current price, especially over the first 1 to 3 lakhs. This tells recent changes drive current values. On the other hand, fertility rates didn't have much direct impacts on house price, which suggests that the price dynamics are most driven by the factors in house market itself. And after that, we use IRF to analyze the short-term shocks. IRF helps us to see how sudden changes in one variable affect the other over time. The result shows that a shock to fertility rates doesn't significantly affect housing price, which remains stable. When the housing price experiences a shock, the fertility rates dip briefly in second and fifth period before returning to normal. This suggests that raising house price may temporarily put pressures on fertility decisions, but the impacts fade pretty quickly. We also saw the fertility shocks didn't exceed like 95% confidence interval when affecting the housing price, which suggests that there's not much direct effects there. And the last, we use the granular clarity test. The granular test checks if knowing the past values of the one variable can help predict the further values of another. The test result shows no significant causality in either direction. So even though the house pricing might have a temporary effect on the fertility, neither variable can predict the other in a meaningful way. So in summary, there is some dynamic interaction between the house price and the fertility rates, but no real predict or causal relationship. Housing price seems to have a short-term indirect effect on the fertility rates. So let's come to the forecasting part.
Okay, I'm Hong Han. I will do the forecast part. And as our data descriptions, we found that there is both house price rate and the fertility rate have the trend. So use that trend, we may do a 5 years forecast. And before we forecast, the Sarima model was chosen to forecast the trend of house price and the fertility rate over the next 5 years. We choose this model is because that it is good at handling complex time series data that include non-stationary component and some several variations. So before we forecast, we have the four process. The first process is about the stationary test. We use two tests here. A KPSS test and a ADF test are both used for our test of stationary. The second process is about the model selections. We need a function called auto-arima. We use this function to find the optimal Sarima models so that we can make a forecast. Third one is about check residues. We will do the residue checks and to make sure that all the features of the residue is like a white noise so that we can make forecast. After the three, now we can do the 5-year forecast rate with the optimal Sarima models. So next page, please. Next page. Now we do the 5-year house price rate forecast. The first process is to use the stationary test. We'll use the KPSS test here. You can see the small p-value here. Small p-value means we cannot reject the null hypothesis, means that the data is non-stationary. And the non-stationary means that we may use some differencing methods in our ARIMA models to make it suitable for forecast. How to solve that is about the model selection. We use auto-ARIMA to find the best ARIMA models to forecast. And after we found that, we check the residues. The three pictures about the checking residues, and we need to analyze each of them. The first op is about the time series plot. As you can see in the time series plot, there is no exact patterns in the time series plot. So that means it totally randomizes the residues. And we can try to see the ACF plot. All the legs in the ACF plot are inside the confidence interval. That introduces that the residues autocorrelations, no autocorrelations. And the last one is about histogram. You can see the approximately bell shape in the histogram indicates that it's normality of the residues. Now, after we checking all three conditions and we make sure that it feature like white noise, so we can do the forecast. And we do the quarterly forecast for the next 5 years, and we also plot it. From the plot, it is apparent to see that there is upward trend on the next 5 years Japanese house price. Okay, let's go to the 5 years fertility rate forecast. Next page. Yeah. So also, we do the 5 year fertility rate forecast with the beginning of stationary test. In here, we use a different test called the ADF test. In here, the p-value is great, means we can reject the null hypothesis. We cannot reject the hypothesis and state that the data is not stationary. So, and also we go to our model selection to choose the best model optimal ARIMA models for our forecast. After we do the model selection, let's go to the check residues. And checking the time series plot, exactly no patterns, so which indicates randomness. And also the ACF plot shows that there's no autocorrelations, and the approximately bell-shaped histogram also shows the normality of the uh, residues. So after checking that, we can also conclude that for the fertility rate, it's still feature like a white noise. Now we can do the last part, the forecast. We do the yearly forecast here, and we also plot it. From the plot, it's clear that we see the downtrend on the 5 year fertility rate of the Japan. Okay, that's my part of forecast.
Okay, so just a brief conclusion. Our study examined the relationship between the housing prices and fertility rates in Japan from 2010 to 2024, as well as a 5 year forecast just to see whether those issues will continue. While housing prices continue to rise and fertility rates continue to decline, our analysis using VAR models and Granger causality tests found no strong predictive relationship between these variables. The results suggest that while rising house costs might temporarily impact fertility decisions, they don't appear to have any lasting or direct impact. This contrasts with other studies, such as those done at the University of Bristol, which found that high housing costs can deter fertility. The difference may be due to Japan's unique demographic and cultural context, including an aging population and emerging housing vacancies. Overall, our findings highlight the complexity of the housing fertility relationship in Japan, suggesting that there's broader socioeconomic factors and cultural factors that are in play and may play a more significant role than housing prices alone. Thank you.
Okay. And the last one is the group pattern. So it's like how we do our work together. So we have less than five members, which is four members, but we participate in the discussing every day, frequently, and allocate our own work according to members' capacities. Then we brainstorming some topics and ideas together, and choose the most interesting one after continuous improvement and modification. Members talk about the problems, activity, and give solutions in time by social platform. That's all. Thank you.